Let's start. Other scams on. Yeah. So let's start off. You need to keep your cams on, everyone, or else you'll be removed from the classroom. So work power energy, again, it's another base chapter, just like laws of motion. So it'll be a little different from work power, laws of motion and stuff, but yeah, things do come up. So before jumping directly into it, right? So if I ask you, when we say work power energy, what is exactly energy? Anyone? What is energy?
The capacity to do work.
Okay. What is work? What is work? Anyone? What is work?
Percent to displacement.
Stuff we do in person display. Okay, now what does it mean?
Is it like what you see a force does?
Now, thing it is difficult to explain what is energy and work. But remember, just like momentum, I explained you. Higher the momentum, more difficult to stop the body. Think of like this. Imagine, 10,000 years back when there's a cave people and all that stuff. And let's say there is a caveman there, and there is a hill there, and he sees a stone, and he sees a similar stone on the ground. Let's call it stone A and stone B. Which stone will you get scared of? A or B? B, right? Now, tell me one thing. Is he really scared of the stone? Is he really scared of the stone? What is he scared of? He's scared that the stone might roll down and might hit him, and it might might damage him. So he's not actually scared of the stone. What he's scared is the height of the stone. You're getting it? Similarly, if there is a lake there with water here, and there's a river which is going very fast, he's scared of what? The river or the lake? The river. So does he mean he's scared of water? What is he scared of? What is making it, the river more scary than the lake? It's not the water. It is the speed of the water, isn't it? So if you ask this cave person, right, yeah, why are you scared of stone B or why are you scared of the river? It is not exactly the stone or the river, but he will say, yeah, B I'm scared because of the height. That B has something more compared to A. Now, what is that something more? He doesn't have the vocabulary to explain, but he definitely knows it has something more. Similarly, the river, water in the river has something more compared to the water in the lake. Now, exactly what is that? He doesn't have the vocabulary for it. You're getting it. So at some point down the line, we define that something, right? Is called as energy. So this is how we can define it. So energy, it's like a quantity possessed by a system due to its position. We call this thing potential energy. And due to its motion. We call this thing kinetic energy. Oh. So that much, we can feel it actually. We definitely know the river has something more, than the water in the lake. But what is that something more? We have to name something, so we call it energy. Then what is work then? Again, these are not technical definitions, okay? These are definitions for you to understand. Technically, it can be something else. So work is nothing but the transfer of energy from one system to another. So basically, the act of transferring energy from one system to another is called work. So if you ask me in pure English, right, what is the difference between energy and work? Energy is a noun. Work is a verb. Okay, correct? Energy is like noun. It's a quantity. Verb is like, it is work is like an action of transferring this energy. So it's a, what do you call it? It's a verb. Clear with this? Any doubts on this? So again, just a layman definition. Like I said, always, whenever you learn something, always understand. There is one technical definition and there is one definition for you to understand. Both are important. Because if you really don't understand what it means, then there's no point. Clear? Now, let's see some more technical definition. Guys, you have to be on time. Huh? You guys can join whenever you want.
So can you go back for a minute?
Hmm.
That's the time.
So, what is work? Now, more a technical definition. So, work is given by integral force dot product ds bar. So the important thing here, we'll keep it simple definition. ds is the displacement. Now, school me said is force into displacement. That's not the actual definition. ds is the displacement of point of application of force. S bar is not the displacement. It is a displacement of the point of application of force. If F bar is constant, then work becomes F bar dot S bar, which can be written as Fs cos theta. So if you take work done in 1D, so if you take work done as integral f dx, this is nothing but area under fx graph. So if you plot an fx graph, now look at here. This is a negative area. This is also negative. This is positive work, and this is positive work. Because on the left hand side, observe this in the fourth quadrant, a third quadrant, you get force negative, displacement also negative. That's why this is positive. First quadrant, both are positive. Fourth quadrant and second quadrant, one of them is negative. We never had a graph on the left hand side normally because we used to draw ft graph, isn't it? Time can't be negative. But in an fx graph, x can be negative. So if someone asks you find the area of work done, so area under that fx graph will give you the work done. Let me give an example about the displacement. Clear? Now, let me give an example. What is this displacement of this thing? This is quite an important thing, actually. A ds is not displacement. Let's say we have a block here, which is 1 meter wide. There is a wall here, which is at a distance of 1 meter. And you're applying a force of F, let's say 10 newtons, at this point A, and this is B. This block hits the wall and gets compressed. To half meter. So this guy becomes half meter. What is the work done by the force? No, anyone? A force of 10 newtons is acting on a block. It hits the wall and it gets compressed. What is the work done by this force? $25? Seriously? From the definition of work done, what should you take? Work done is force into, whose displacement will you take? Displacement of point of application of force. Where are you applying force? At A. So you are interested in the displacement of A, right? So if you look at this thing, look at how much did A move here. So from here to here, it is 2 meters. So this was half meter and this was 1 meter. That means the displacement of A is 1.5 meters, whereas displacement of B is 1 meter. Did you see? All the points on the body have not moved same distance. School mein what used to happen, all used to have same distance, so you never had a problem. But what if the displacement is not same? So what is the answer here? So it will be 10 into 3 by 2, 15 joules. So be careful with that. When you say work done is force into displacement, which displacement are you talking about? You can't, there's nothing called displacement of the body. S is the displacement of the point where you applied the force. I don't care what is happening to B. I'm applying force at A, it will take the displacement of A. Is this clear, everyone? Have a look at this. Clear? Let me show one more example. Ritu, clear with this? Malika? Mehan? Arjun? Neil? Can I go ahead? Abhinav? Venkatesh?
Yes.
Venkatesh, I can't see you, right? Do adjust your cam. No, this example. Now, what about this guy? I have this chapati ka dough or clay, whatever you want to take. Atta hota hai na, chapati ka dough, that one. So you're holding it. After some time, what happens? This thing will start stretching. What is the work done by the force? What is the work done by the force? Again, remember the definition. It is work done is force into displacement of point of application of force. Here, SA is 0. Therefore, work done by force is 0. Then who is stretching this atta? Gravity, na? The gravity would change. The weight vector will go down. So here, the work is being done by gravity. The work done by gravity is not 0. Same thing. If I give one more example, let's say we have a staircase and we have a boy here who is walking on the staircase. Can you find work done by boy on staircase? Work done by staircase on boy. I just want whether it is positive, negative, or zero. I don't want the value. Again, listen to the question. A boy is walking on a staircase. He's climbing up. What is the work done by boy on the staircase, and what is the work done by staircase on the boy? Try. There are two questions here. Okay. Think about both of them. I'll give you another 30-40 seconds. I'll show you. I just want whether it is positive, negative, or zero. Okay, we have different answers: negative, positive, zero, positive. There are two questions. You have to answer both at the same time. Don't answer one at a time. I don't understand which one you're saying. Or at least mention first one is positive, second one is negative, whatever. If you just put zero, positive, what should I assume? Okay. Let's see. Work done by, first let's see, work done by boy on staircase. So here, what is your system? Your system is staircase. And what is the boy doing? The boy is pushing the staircase. So how is the force? N. Where are you pushing this? You're pushing this point A here. Is the point on the staircase moving? No. The point on the staircase does not move. So even though you're applying force on the staircase, they do not move. Therefore, work done is zero. The boy is not doing any work on the staircase. The other one, this is more interesting. Now, if you look at the boy here, when he's climbing, look at this point here. This is point A, this is point B, right? Now look at A. At point A, there's a force. This is the force due to staircase. But is A moving? When your leg is in contact with the ground, but A is not moving. That means work done on A is zero. Is B moving? B is moving, but is there any force on B? B is moving, but force on B is zero due to the staircase. Therefore, work done on B is also zero. So work done by staircase and boy is also zero. No one does any work. Now you need to understand in terms of logically socho. If the staircase does work on you, what is the meaning of this? If you go and stand on the staircase, you'll go automatically up. Does that happen? Think about it. If you say staircase is giving you work, matlab kya? Staircase gave you energy to go up. An escalator will give you energy, isn't it? Escalator will give you. Staircase won't give you anything. So work done by staircase on boy is zero. Are you guys getting this example? So you literally have to see, I know boy is moving. I don't care about that. You need to see the point where the boy is, touching, being in contact. So how is the boy going exactly? What you're doing is you are using your own energy, your legs like springs, and you're actually using the ground to transfer your energy back to yourself. It's your own energy that you're using to climb the staircase. That's why you get tired. Imagine you sitting on this escalator and sit there for 1 hour. You will never get tired, right? The escalator will take you. All clear with this? Now, let's see a problem based on this, based on escalator. Now you guys try to answer that. But everyone clear with this pitch? Huh, Palaksh? Artika, clear with this? Neil? Rastika, clear, na? Great. Let's do something weird. So we have an escalator which is going up with you. And you being an adventurous person, you decided to go down the escalator with V. Ever done that? Now, there are three possibilities. Case one, u is greater than v, means escalator is going faster than you. Case two, u is equal to v. Case three, u is greater than, u is less than v. Three possibilities now. They are running faster than the escalator, slower than the escalator, equal to escalator. Now, what I want you to do in all the three cases, find work done by, first question, man on escalator, escalator on man, work done by gravity on man. So three questions, three cases, total 9 answers will come. समझ में आया question? Find work done by man on escalator when v u is greater than v, u equal to v, u less than v. Find work done by escalator on man when u greater than v, u equal to v, this thing. Work done by gravity. So these are 9 questions, everyone. Three cases, three possibilities. First, let's do for u greater than v. If you do one, you'll get the hang of remaining.
Like positive, negative, or zero, right?
I just want positive, negative, zero. We don't want values. We just want positive, negative, zero. Think about them. Take a minute for the first case. Arjun, don't do that. For one case, you get all these three. Doesn't matter, Axel. Get however you want. Try. You got 2 minutes. Think about all of them. Start with anyone. Anyone didn't get the question, please ask me. I'm sure you must have done this. Never done this. You need to be a little crazy to learn physics. You shouldn't be such a good person. You should do sometimes some evil things for the greater cause of science. It's like not because you have to be an evil person. मुंबई में तो security catches you. Let's see the first case. Let's take the u greater than v ka case. Means escalator is going faster than the van. So let's say it's somewhere in the middle, okay? So just put him somewhere here. Now see what happens. Let's look at the man. Or let's look at the escalator. If you look at the work done by escalator on man, so when you try to draw the man ka FBD, this is how it looks. You know, one leg is on the escalator and the other leg is going down. So we are only interested in this point here. So how is the escalator applying force? Escalator is applying force this way. And how is this point moving? This point is going this way. Do you agree? You need to understand, see, don't look at the man. I don't care about the man. You need to look at the point of contact. The leg is still on the escalator. The other leg is going down, but one leg is still going up with the escalator, right? What is the angle between them? Theta is acute. So what is work done by escalator on man? Positive. Kind of makes sense. Every time you're trying to get down, the escalator is pushing you up, giving you energy. If you take work done by man on escalator, so now if you take the escalator, same thing, you're pushing the escalator down, but the point where you're pushing is going up. The angle is obtuse. Basically, you're stealing energy from the escalator. And what about if you, since u is greater than v, eventually man will go up. Since u is greater than v, man goes up. So if you look at the man, mg is acting down and the displacement is going up. The work done by gravity is negative. Clear with this? Now, can I do for u is equal to v case? Now, interestingly, what happens, you know, if you take u is equal to v or u is equal to all three cases and u less than v, the answer is same. This and this answer will remain same. The gravity answer only will change. Check it out. For all these three cases, the first two ones are same. It doesn't matter what is the speed of the escalator. Think about it. Escalator will always go up. So being this point will always go up and the force will be always this way. Doesn't matter how the escalator is going up. So A and B will have same answers for all three cases. Try to understand that. So for case C, if you're going with U less than U greater than V, man goes up. Mg is down, displacement is this way. The work done is negative. If U is equal to V, man does not move only. Man is at same position. Work done by gravity is 0. If U is less than V, man is running faster, man goes down. Work done by mg is positive. Okay. So the lift ka speed will depend, right? That will only change the C equation. A and B ka answers won't change. But for V greater than, again, Anika, the point here is you are talking about displacement of the leg which is in contact. We are not talking about man ka displacement. When you're jumping down the escalator, one is leg is on the escalator, one leg is in the air. Agreed? That leg which is on the escalator, how it is going up? It is going up or down? That will always go up, right, with the escalator. Why are you able to come down? Because your other leg is going faster than that. You're stepping down faster than you're climbing up, isn't it? But if you observe the leg which is on the escalator is also. When you're getting down, if you observe how you're getting down, this leg is still here, isn't it? So as you're trying to get down, this leg in that sometime it will go upward, na? And then you jump here, isn't it? Then you remove this leg. But during that time, the point is still going up. It doesn't matter with what speed you go. You go slow, you go fast. This leg is always going up. I hope everyone agrees with that statement. So if you observe how you walk on an escalator, that's what happens. One leg is going up always and one leg is coming down. So if your other leg goes faster than the escalator, you will eventually come down or else it will drag you up. Please check this thing. It's a good one. Simple one, but ask me if you're confused. Clear? Any doubts? Next one. Now, then, clear with this, Ronak? Anusha, Yasha, clear with this? Arjun, Rehan, Aditya, clear with this? Next thing, a pencil is used to draw a circle of radius r on a paper. Friction between pencil and the paper is F. So basically, we have a paper like this. You went and you drew a circle like this. So this is a pencil there. You're drawing a circle. Find work done by pencil on paper. So the circle का radius is R. Work done by paper on pencil in one revolution. Friction between them is F. So if you actually take the pencil like this, you know how the friction will act, like opposite to the pencil. Pencil is used to draw a circle of radius R on a paper. The friction between pencil and paper is F. Find work done by pencil on paper, paper on pencil in one revolution. Try. Again, I just taught you one thing. Work done is F bar dot ds bar, where ds is the displacement of point of application of force. First, we are just playing with that. Try. And I'm sure you understood the question. How many times you must have drawn on the paper? Why second part is 0? Here now I'll tell you one statement. Since the displacement is 0, work done is 0. Is that true? You can listen to the statement. If the displacement is 0, work done is 0. That's a big blunder statement. We will see when that is not valid. Schoolmate used to work. Try. Get the answer. Here you will get something in variables. You will get the answer in terms of F and R. Okay. The first part, fine. Second part. Try. Everyone, you got 2 minutes. Figure it out. And type both the answers together. Take a minute, 2 minutes. Get it. Try. Anyone still confused with the question though? Please ask me. I'll explain you again. Niyadrit. First part. Yasha, you messed up the first part. Let's see. Work done by pencil on paper. Now listen carefully. This thing is important. Certain things get cleared. Like I keep saying, right? No matter how much you read the theory, concepts don't get cleared. They get cleared only when you solve enough problems. So work done by pencil on paper. So paper is my FBD is my paper. Yeah, drawing FBD of the paper. So this is the circle. And let's say your pencil was going like this. So how is the friction on the paper? It will be in the direction of the pencil, right? the friction on paper is in the direction of the pencil, meaning that motion. Pencil it will be opposite, but paper it will be in the forward direction. Great. But tell me one thing, is the point on the paper moving? You're applying force on the paper, but is the point on the paper moving? What should you take? Force into displacement of the point of application of force. You're applying force on the paper. Is the point on the paper moving? Now, until unless you're scratching it and tearing the paper, it is not moving, right? The points on the paper do not move. Even though you're applying force, points on the paper do not move. Displacement is 0. Therefore, work done by pencil on paper is 0. Clear? Now, what about the second part? The second part, pencil is moving. Try. It is not 0. Think I'll give you a minute now. What is work done by pencil on paper? You have to tell with sign also. Sign matters. Negative. I want to value your address. I don't want just a sign.
So,
God. Bol na.
so can you explain this part again, like the work on pencil on paper is 0?
Pencil on paper. Displacement क्या था point का? You should take whose displacement type, displacement of the point where you applied the force. आप force कहाँ पे apply कर रहे हो?
So on the
Paper.
paper.
Is the paper moving?
No, sir.
So displacement 0. So what is work done?
So, but that point on the pencil is moving, right?
You're talking about whom? Paper or pencil? Let's be clear, first of all.
Paper.
Whom are you talking about? Paper.
Yeah.
तो फोर्स पेपर पे अप्लाई कर रहे हो तो पेपर का डिस्प्लेसमेंट देखना था.
Hey.
Is the paper moving? No. So that's what I'm saying. Be clear with your system. Now the second part, what you're asking us, work done by paper on pencil. Now what is your system? What is your system?
Pencil.
Pencil. Now if you look at the pencil ka tip, if you assume it is going this way, look at this everyone. The friction will be this way. The displacement will be this way. Now, no matter how far it goes, you'll always observe friction will be this way. So pencil may it will be opposite, whereas the displacement will be in the forward direction. So at every instant, you'll observe the frictional force and the displacement ds bar are anti-parallel. Are you getting this? Now, an important thing here, see, and just get back to this. When we wrote work done is integral f bar dot ds bar. If f bar is constant, this thing becomes f bar dot integral ds bar. This is f bar dot s bar. So here, if in a round trip, if displacement is 0, right, work done is 0, only if force is constant. Tell me, is the friction constant here? Direction change हो रहा है ना? Here friction का direction is changing. Do you get the difference? So here, if I try to take the work done, it is integral f bar dot ds bar. Now listen carefully, see what happens. Integral, this is mod f mod ds cos 180. So minus mod f is constant. You are integrating mod ds bar. Can you tell me what is the difference between integral ds bar and integral mod ds bar? This is displacement, isn't it? You're integrating a vector. What is mod ds bar? You're just adding all the small parts ka length, na? This is the distance, isn't it? Are you getting the difference? So this guy is minus f into 2 pi r. This is not 0. So you're integrating mod ds here. You know, how does a constant force look like? Let me show you that. If you wanted a constant force, it should look like this. F bar, F bar, F bar. This is a constant force. Magnitude is same, direction is same. In this scenario, work done will be 0. Here, work done by F bar in one revolution will be 0. Because when you take your work done, this would be F bar dot S bar. This S bar is 0. Displacement is 0. Are you getting the difference between constant force? The direction, magnitude, both should be same. Now here, the magnitude is constant, but is the direction same for friction? So that's why you can't say that. So be careful with that statement. You know, displacement 0 to work done 0. It's a blunder. Everyone clear with that statement there? So I'll add that thing here. If displacement is 0, work done need not be 0. It depends on the force. And second thing, did you observe something here? The work done by paper on pencil is 0, but whereas work done by paper on pencil is F is 2 pi r. They're not always equal and opposite. Newton's third law is not valid here. Newton's third law में what? If I give you force F, you'll give me force F. Work में ऐसा कुछ concept नहीं है. If I give you work W, you should give me work W and back. So that is also one more point here. We don't have a concept of third law here. We don't have any similar concept to third law. That is, if work done by AB should be equal to minus of work done by B on A. Work done on A on B is minus of work done on B on A. And this is blunder. So there is no concept of Newton's third law here. If I do work, you have to do work, not necessary. Please check it out. So these are the thing. Just displacement is 0, work done need not be 0. If force is constant, displacement is 0, then work done is 0. School mein you never handled the variable forces, na? That's your schoolmate used to work. Please check this out, everyone. Here, F bar is changing. Don't use F bar with S bar. Clear with this? Any doubts on this? Everyone, clear with this page. Aryan? Anika, clear with this? Palak, Neil? Then have a look at this page also.
So can you go to the previous page?
Hmm.
Yes, okay.
Clear? Can I go ahead? Let's do something little easier. Ten kg block, mu is 0.2 and force is 20 root 2 newtons. And this angle is 45 degree. Initially at rest. Find work done by force and friction in 2 seconds. Hmm. Try, everyone give it a try. Again, think like this. What is work done? Force into displacement. So how do you get displacement? Displacement you get from kinematics, ut plus half it square. How do you get A? A you get from loss of motion. Draw your free body diagram. That's what you should always think. Why 0, God? It is 0.
No, sir. Sorry, I read the question.
I know you'll get 0. But think.
Yeah, I put the force as horizontal. I forgot that about that.
How many of you are taking n is equal to mg? That's your mistake. N is not mg, gods. FBT draw karo, दिखेगा अच्छे से. N is not mg here. There's a vertical component of force also. See, start the free body diagram. 800. यार बहुत बड़ा वैल्यू है. F cos 45, F sin 45, frictional act backward, normal reaction, your own weight 100. And will be 80 newtons. 100 minus 20. F max is mu into n. That is 0.2 into 80. That is 16. So here this block can move. You have to always check. Since F cos 45 is greater than F max, block moves. So you're done. So what is this thing? Acceleration horizontally 20 minus friction. Is there me? 20 minus 16 is 10. So acceleration would be 0.4 meters per second square. What's the displacement? Ut plus half at square, u is 0. 0.4 into 2 square. 0.8 meters. What is work done by friction? Minus F into displacement. That is minus 16 into 0.8. That is minus 12.8 joules. What is work done by friction of capital F? Fs cos theta. That is 20 root 2 into 0.2 into 1 by root 2. That would be 4 joules. No,
It is 0.8.
0.8. 16 joules. Check. See where it is going up. Please check your steps, everyone. Free body diagram, find the friction, put the forces, get the acceleration. That is loss of motion. Once you got acceleration, get the displacement from kinematics. Once you got the displacement, your job's done. Clear, everyone? Next one.
So,
Need
so
also
in this minus Fs will be the answer for what?
friction.
And then that will be work done by force now. That Fs cos 45.
That is 16 joule. Clear? I hope everyone is clear with this. Next one. So we have two blocks M and 2M. We have an observer on the ground A, and we have one more observer on block B, on 2M. So there are two observers here. Massless observers. Observers don't have any mass. Initially at rest. Find work done by tension on the blocks. in 2 seconds. As seen by A and B. Ritu, so far everything clear? Are you there? The screen got stuck.
Yes, sir, it's clear.
Okay. Chalo, get this thing. We have a pulley system. I hope you remember this thing. NLMA we did. So find the work done by the tension on M and 2M, 2 blocks, as seen by A and as seen by B. So total 4 answers will come. 2 questions, 2 cases. Let's get this.
So can you see me now?
Yeah, it's better now. Again, I keep telling this. We will not do any new things. We will do something which we already done. We'll take that and we'll play with that only. We have seen all these questions before. But there we talked about displacements and stuff. We are talking about now work done. Find work done by tension on the blocks. So there are 2 blocks in 2 seconds, as seen by A, as seen by B. A is on the ground frame. B is on 2M. Get this? How to do first thing? Since you want work done, it is forced into displacement. First, you need to find tension. And then you need to find displacement. If you got these two, your job's done. If you have revised your NLM, you would have seen this. First thing, let's find tension. Do you guys remember the tension ka formula? Two M1 M2 by M1 plus M2G, which is 4 mg by 3. You can check it out in Atwood machine. What is the acceleration? G by 3. That also you'll get it from net pulling force method. Or for this thing, we even have the formula also, M2 by M2 M2G. So the displacement will be ut plus half at square half a. So this would be half a is g by 3 and time is 2 square. That is 2g by 3 meters or 20 by 3 meters. This is the displacement. Now see carefully what happens. If you solve with respect to A on block M, tension T is upward, displacement is also upward. On 2m, tension is upward, displacement is downward. The work done on m is T into S. Work done on 2m is minus T into S. Agreed? Where T ka value is 4 mg/3 and S ka value is 2g/3. But if you ask B to solve the problem, we will have an interesting perspective. Now try to understand this. This is M. This is 2m. When this thing went up S and this thing went down by S, what will B think about M? B thinks M has gone double the distance now. It's a relative velocity. So work done on M will be T into 2S. And work done on Tm will be 0 because he will think 2m is not moving. B thinks 2m is always under my feet, it is never moving. Clear with this, everyone? 8 mg square by 9.5. Please check the steps. So depending on the frame, your answer changes. So work is actually a frame dependent quantity. Work depends on frame of reference. So depending on where you're seeing this from, you can get different answers. Please check this thing, everyone. Clear, everyone? Any doubts on this thing? Anika, Palak, Niranjan, clear with this? Neil, Aryan, Adrit, Mehan. So be careful with this thing. Huh? So depending on the frame, answers can change. We have a pendulum here. So this is point A and this is point B. This is fixed here. Length is L. -90 degrees. So pendulum goes from A to B under the action of 3 forces. F1, F2, and F3. How are these forces? F1 is always horizontal. Meaning this F1 force will be always like this. No matter where you go, F1 will be like this. F2 is always tangential. Meaning this force will be along the arc. F3 is always directed towards B. You're getting how the three forces are? This F3, these kind of forces are called central forces. When the force is towards a certain point, we will talk about this later on. But for now, just keep it in. It's called central force. If the force is always towards a certain point, it's called a central force. Find work done by three forces. Is the question clear? We have a pendulum of length L goes from A to B in a quarter circle. So there are three forces acting in this process. F1 is always horizontal, F2 is always tangential, F3 is always looking at B. Find the work done by these three forces when it goes from A to B. I hope the question is clear. Try. Okay, we have one answer so far. No, that's not the right answer. Anusha, you got it right. Aryan, what is that? F290L क्या होता है? Angle should be in radians, gods. Arc length R theta, theta is in radians. Try. I'll just get some water and come. Give it a try, give me a minute. Let's see. We just have to manipulate that formula a bit. But it'll be quite useful when you're solving problems later on. See, when you're writing the formula here, we write it as integral mod f mod ds. I'll just put f, okay? F ds cos theta. So my suggestion would be, there are two ways we can include this. When you're saying this is f, and let's say this is ds, and this is theta, you can write this thing as work done is integral f cos theta into ds. So this would be force in the direction of displacement. This is one way to write this. Till now, what we are writing? You are writing f ds cos theta. This was displacement in the direction of force. So either you can keep force constant and write displacement in the direction of force, or you can keep the force in the direction of displacement. So now looking at this second part here, so this is what we are more interested in. So we can simply write force into, so we can simply put it as force into displacement in the direction of force. Again, for constant magnitudes. So now when we look at our problem here for F1, let me show it on the next page. So how is this force F1? F1 is always horizontal. So what is the displacement here? Horizontal distance, no? Do you agree? Displacement in the direction of the force. Force is always horizontal. You should take a horizontal displacement. So work done by F1 will be F1 into L. The second one, the force is always tangential. So displacement will be in the direction of force. So we are taking this displacement here, arc length, which is pi L by 2. The work done by F2 will be F2 into pi L by 2. The third one, the force is always looking at this guy. So that means you're interested in this displacement, which is L root 2. The work done by F3 is force into displacement in the direction. You're always looking at with L root 2. Check your answers. Right, Yasha, you got that right. Nehan, you're right. Anika, you got it. Adrit, you got two parts right. Yeah. Clear with this? Check it out. So basically, it depends on how you want to manipulate the formula. You can write displacement into component of force in the direction of displacement, which you did in school, or you can write force into displacement in the direction of force. So both will work. Please check.
So can you show the previous page for a minute? Yeah, so thank you.
Next one. Now, Swastika, clear so far? Malika? Partika, clear with this? Arjun? Palak? Ritu? Next one. We have a random incline like this. Height h, length L. Friction is mu. It is rough. So we have a block of mass m. Slides slowly without losing contact. So it won't fly off. Find work done by friction and gravity when it comes down. And here I want to one question like, what happens if it is not moving slowly? Why should it move slowly only? Meaning if it is going with some constant speed, kya problem? So first let's do the first part, and then you think about what happens if it is going with velocity. So we got some weird incline, height h, length L. Rough friction, it is coefficient of friction is mu. The block is gently sliding on it. Find the work done with the friction and the gravity when it has completely come down. It is moving slowly. So the second part of the question is why it should move slowly. Try. Try everyone. We have an answer. Okay. Okay, that we got the one part. Anusha, no, that is wrong. Okay, Ronak, so what happens if there is a velocity? Figure out that part also. Nee, Monica. Vidyut, you are right about that part. Find the work done due to friction. And Mika, you messed up the sign. Everything else is fine. See. When this is sliding here, at any instant here, take a small path. Take a small ds. So this is theta, this is dy, this is dx, and this is ds. The forces acting on this will be friction, which is F max because it is sliding. This will be like normal reaction. And we get from here, this is mg cos theta. And this would be mg sin theta. So here, remember, theta is changing. Every instant theta is variable. So we get here n is equal to mg cos theta. F max will be minus mu mg cos theta. So work done by friction will be integral minus friction is mu mg cos theta into the displacement is ds. This is minus mu mg integral ds cos theta. So but from this triangle here, ds theta dx and dy. ds cos theta is nothing but dx minus mu mg integral dx. So x coordinate will go from 0 to 1. This will be minus mu mgl. That's the work done by friction. Now what about work done by gravity? Remember, mg is a constant force, so you can write directly minus mg j cap dot product. Work displacement will be li cap minus h j cap. That will be plus mgh. For a constant force, you can directly take force into displacement. So displacement is like what? Li cap and minus h j cap. Friction is variable, so you have to integrate. Check this out. And the best thing about this answer is independent of the path. Question is not over. Why should it go slowly? Someone tell me that. As long as the horizontal length is same, you can take any path, meaning this path can be like this path can be like this. As long as you're sliding slowly on this path, the work done by friction is always same. Why should it go slowly?
Sir, we could have done the first part using energy conservation also.
Yeah. What is energy
Huh?
conservation? What is energy conservation?
Initial energy is equal to final energy.
Why, Behan? Why will you do that?
No, like at the topmost level, it will only have potential energy.
Uh-huh.
And when it goes down, it will have it will be like the force of friction as well as the kinetic energy will be applied.
What is kinetic energy here?
Like when it will go down, the kinetic energy will be half mv square.
What is V? Why पूछ रहा हूँ?
No, v will be a variable.
Okay.
and then if we use using work energy theorem also we can.
तो वही है बोलना. You're like that, you know. In school, na, when I used to, teacher used to ask, Arun, tell me the prayer. I was like, ma'am, you know, prayer, mya, 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 amen. Prayer हो गया ना.
No, like if we do it using work
करो
energy
करो.
theorem, work
नहीं
done by
आएगा.
friction
God,
plus
Rehan, when you say work energy theorem, na, here, work energy theorem is what? Work done by external force is equal to change in kinetic energy plus change in potential energy.
हाँ.
You don't know kinetic energy. Velocity is not given. एक काम करो, करके मुझे WhatsApp में फोटो भेजो. यहाँ पे एनर्जी कंजर्व ही नहीं है. गॉड. Okay, think about it, but still you send me your working na, you think it will come na, send it, work, do the working and send it to me. Let's see if you're getting to great. Okay, why should the velocity be there? Some person says, sir, it will slip and fly off. Okay, because it flies off tangentially. You guys are answering like, you know, these medical students only. They also give this kind of weird answers.
No, but it will lose contact, no?
Chal, it is in contact and going slowly. Chal, abhi baat ho. It is going with some speed, but it is not losing contact. Abhi baat ho. Someone says it
External
will
forces
depend
will be
on.
there to keep
If
it
there's a
in.
velocity, there will be acceleration. Why there will be acceleration? It is going with constant velocity. Someone is applying an external force and making it go with constant velocity. Ah, Dhrit, you're saying something? Anyone? देखो क्या होगा पता है? When you're taking this path, at this instant, the normal reaction will be n mg cos theta. You are going in a circle, so there will be a centrifugal force. So normal reaction will be mg cos theta plus mv square by r. Isn't this what we did last class, the last question? Circular motion में था.
So the radii of curvature thing.
Isn't this the question we did?
Yeah.
Normal reaction is mg cos theta plus mv square by r. Now, do you know radius of curvature? We don't know r. It is changing every instant. So therefore, velocity has to be zero. If v is not zero, I don't know how to solve the problem. If body has velocity, we can't find n. If you can't find n, you can't write f is equal to mu into n. Story is over. You can't solve the question. That is the reason velocity has to be zero. It has to go slowly. So v has to be negligible. We can solve if v tends to zero. Clear? Why it doesn't work with some velocity? So be careful with that. Advanced question जैसा आता है, you know, they'll give you some 1 meter per second square, 1 meter per second, and everyone remembers this answer. Huh? Standard question. Everyone remembers the answer. They'll mark it and come. And fourth option होगा, you cannot find or none of this. That's what happened. You remember the answer, but you don't know why and what. So a little into details. Please check. I hope everyone got the logic. Why it doesn't work with velocity. Flying off, that is not the reason, but yeah. Clear? Next one.
But if it goes too fast, will it fly off?
It is going with a constant velocity without flying off. बोल देंगे ना question में. It is given. Don't worry about flying off part. It's like medical students, na? I gave 2 blocks. I said friction is there. I'm applying force. सबका एक ही problem था. Sir, what will happen? You know, what if this block falls down? I said, यार छोड़ ना यार, block doesn't fall down. Find the acceleration ना. Sir, but eventually it will fall down ना. I said, यार, when eventually falls down, we will see then ना. Right now, find the acceleration. They were like too obsessed about the block falling down from the other block. अभी ठीक है, अभी क्या कर सकते हैं? Clear this? Next one. This is a good one. Let's see. A body moves from point A, which is 1, 1, to point B, 2, 3. under the action of first force F1 bar 2y plus 3j. The second one F2 bar xi plus yj. Third one F3 bar is yi cap plus xj cap. Xy square plus find the work done with these four forces. So question is like this: body is going from A to B under the action of this force 2y plus 3j. Find work done. If the force is xi plus yj, find the work done. If the force is yi plus xj, find the work done. So there are four questions. Get this. I'll do one thing, man. I'll just show you the first one, okay? First one is quite easy, actually. You can directly F into R bar. But let me show you a more generalized way. Remember, the work done ka formula is integral F bar dot displacement, which is again known as dr bar. We know for a vector, this is R bar, x comma, y comma, z. R bar will be xi cap plus yj cap plus zk cap. So dr bar will be dxi cap, dyj cap, dzk cap. So from the first one, the work done formula will be 2y plus 3j dot product dxi cap, dyj cap. This is a general way of doing it, okay? But first case may f is constant, you'll get the answer fast. If you do the dot product, you get integral 2 dx plus integral 3 dy. You're going from A to where? You're going from A to B. So you're going from xa to xb, which is 1 to 2. You're going from ya to yb, which is 1 to 3. This would be 2. X limits will go from 1 to 2. 3. Y limits will go from 1 to 3. This guy will be 2 into 2 minus 1 plus 3 into 3 minus 1. This guy would be 8 joules. This is how you normally do this question when you have to integrate. Luckily here, you could have done it faster. Work done, you can write as f bar dot s bar, since f bar is constant. That would be 2y plus 3j dot ab bar. And what is ab bar? B bar minus a bar. So 2 minus 1 I cap, 3 minus 1 j cap. This would have been 2 plus 6, 8 joules. There, this was easy, but this process is important. Once have a look at this, how I did. So whenever you have to integrate, this is what you do. Take dr bar, take that f bar, put there and integrate. Now, can you solve for the second part? Second is what? F2 is xi plus yj. What is third one? Yi plus xj. Chalo, use this as a reference and solve. You are going from A to B. A is 1, 1 and B is 2, 3. I showed you for F1. You do for F2 and F3. Okay, 11 by 2, 1. 11 by 2 or 1, right, Aditya? Second is fine. Get the third one. Please have a look at this page. Ask me if you're confused. Right, Anusha. 11/2 is fine. Most of you got it right. Get the third part. Since here it is constant, there was no problem. But if it was variable like F2 and F3, you can't directly say force into displacement.
So can you show the question?
Why here a question? I wrote it here only.
No, huh.
ये भी लिखा ना, got red में. Find work done by F2 and F3 when you go from A to B. ठीक है, I'll show you the question. This will make you happy. C is 5, okay. Try F2. Should I show the second one? 107, okay. Let's see, try. I'll give you a minute more. Second one, see. The work done will be xi yj dot dxi dyj plus dzk. So this would be integral x dx plus integral y dy. You're going from xa to xb. You're going from ya to yb. So that would be x square by 2, limits 1 to 2, y square by 2, limits 1 to 3. That will be 2 square minus 1 by 2, 3 square minus 1 square by 2, 11 by 2. Third part, how will you do? You can't remove y out of the integral directly. Okay. Have a look at the second part. Right, Ajit. Third क्या करना था? yi plus x. Think I'll give you a minute. Listen to this thing. The third one, you can't solve this directly. The work done is integral y I cap plus xj cap dot dx I cap plus dyj cap plus dzk cap. This would be integral y dx plus x dy. Now listen carefully. You can't integrate these functions directly. So what we do, you can't integrate them together separately, but together you can do something. This can be written as integral d of xy. These kind of functions are called perfect differentials. Look at this thing, d of xy product rule. When you differentiate x, y will be outside. When you differentiate y, x will be outside. You getting this? So what you're integrating is not dx or dy. What you're integrating is d of xy. So basically, we have created xy is a new variable. You're getting it? So we are integrating, we are treating xy as a new variable. So what will be the limits then? So basically what you can do, if you want, you can put xy is equal to some t. Then ये हो जाएगा integral dt. So what is ta? Ta will be xa, which is 1 into 1. Then the limits will be ta to tb. So ta will be 1 into 1, which is xa, ya. tb will be xb, yb, which is 6. So basically, you're integrating from 1 to 6. So this guy will be t, limits will go from 1 to 6. This will be 5 joules. These kind of functions are called perfect differentials. Example, if I'll give you one more example, let's say t of x square y. This guy would be 2xy dx plus x square dy. So any function that you can write in terms of d of one single term is called a perfect differential. Clear with this logic, everyone? This is very important. This again we'll encounter in gravitation and electrostatics. 2 more chapters will see this concept. Have a look at this, what I did. You can't integrate y dx, you can't integrate x dy, but together it will become d of xy. So you're treating that entire xy as a new term. So the limits will become xa ya to xb yb. You could have done directly here also. Please check. So don't do like this thing. यहाँ पे ना don't write integral y dx is y into dx. ये wrong है. Y is also a variable, right? We don't know why is changing. Please check this thing. All clear with this? Now can you do the d part? D part is also perfect differential. Try. You got a minute or two. How to do this thing? Integral 2xy cube three x square y. So this would be 2xy cube dx plus 3x square y square dy. If you actually clearly observe, this guy would be d of x square y cube का function था ये. Did you guys figure that out? So you can put x square y cube is equal to t. So ta will be x square y a cube, which is 1. tb will be xb square yb cube, which is 2 square into 3 cube. That is 27 force. How much is that? 108. So this will become integral dt. Limits will go from ta to tb. 107 joules. Check. Clear, everyone? Clear? Got this thing? This is important. Last one for the day. Easy one. Let's see. We have an fx graph. $20. This is 10 Newton. Find the position where the total work done becomes 0. We have done this kind of things in graphs. Finish up. Last one for the day. So this is an fx graph. At what position will the total work done become 0? Hope everyone has given the test. I'll post the results tomorrow with the paper. Right, Adrit. Others, try. I got a minute more. Aryan, that is wrong. Anusha, that is right. Anika, you're close by. You just goofed up something there. Hmm. 35, 20 here. See now, what is total work done here? Positive area plus negative area, right? So let's say, first of all, find this area here. How much is this area? This will be 10 into 10, 100. How much is this area? Half into 10, 50. So when you go below the x-axis, let this be x. Let this coordinate be x. Then this length will be how much? X minus 20. This angle is 45 because this is also 45. That is 10 by 10. If that is x minus 20, this is also x minus 20. So this area will be half into base into height x minus 20 square. Since the total work done is 0, positive area should be equal to negative area. Positive area is 150. Negative area is half into x minus 20 whole square. You have to take that. I think you guys took this as x. If you took this as x, you have to add plus 20 later on. So this will be 300, will be x minus 20 whole square. X will be 20 plus root 300, which is 10 root 3. Check. I took the final position as x, so that width will be x minus 20. If you take the width as x, then finally you have to add plus 20 to it. Clear with this? There. So next class when we meet, we are going to continue from here. We'll do few more problems on this work part, and then we will do something called conservative forces and work energy theorem. It's a pretty good chapter. Like, you know, laws of motion is one type of a chapter. See, in entire mechanics, right? You have two set of weapons. One weapon is force and torque equations. We have not done torque yet, but force we did. The second set of weapons is conservations. There are three types of conservations: energy, momentum, and angular momentum. So we will get that first part here in this. Okay, so with that, we'll wrap up for the day. So I'll send you the paper by tomorrow. So do resolve the paper. Whatever doubts, if you find any corrections in the paper, you can send me in WhatsApp. I'll see if there are any corrections.